Alright, let's talk about centroids. Centroids are a useful thing in engineering. Basically, we're just trying to find the center of gravity of something. Go ahead and write that down in your notes, and I'll tell you as we go along what you need to jot down. Graphically, it's labeled with this little icon. Also, don't forget, as we move through this, I'm going to talk fast. You can pause if you need to. And a lot of times we need to know the center of objects. You know, think of a plane when it takes off, where they pack the luggage, where the fuel tanks are. That's just one really simple example of why we care about the center of mass of different objects. I'm kind of breezing through some of this because I'm going to hit it a little bit later. So we need to find the centroid of some pretty basic geometric shapes. And let's go ahead and get to that part. So this is pronounced, the way you read this, you'd say X bar. So go ahead and jot down this. Picture while I'm talking to you. So X bar for a square, for example, is basically half its base and half of its height. It's just a fancy way to say the center of a square. So again, X bar, Y bar. X would be half its distance, or the center, in the X direction. Y bar is half in the Y direction. Base divided by 2, height divided by 2. Let's do a triangle now. Again, go ahead and sketch this up for me real quick. And same idea, except for with a right triangle like this, it would be a third. X bar is base divided by 3. Y bar is its height divided by 3. While we're here, take note of the direction of the triangle, meaning it's pointing towards the right. If you use a triangle in your centroid that you're going to make, I would make it a right triangle like this, and facing the right, so to speak. Last one is a semicircle. And notice we don't need to find the centroid in the X direction, because it's just simply half, right? Whatever this distance, it would just be half. But we do need to find the centroid in the Y direction, and the equation for that is 4r divided by 3 pi. So 4 times its radius divided by 3 pi. Go ahead and jot down, notice these equations are the same, it just depends if you're finding the X bar location or the Y bar. Go ahead and jot these two down, just the X and Y. We're going to get to those in a minute. And one other thing I want to review, which is this slide. The area of these shapes, go ahead and sketch those out real quick. Area of a square is just side squared. Area of a rectangle, width times height. Area of a circle, pi r squared. Area of a triangle, half base times height. Alright, I'm going to switch to a different slide here. Let's see what we got. Alright. Go ahead and copy this shape. What I want you to notice as you're sketching is that this is broken up into 3 shapes. Shape 1 is this rectangle, shape 2 is this triangle, and shape 3 is this square. And I also want you to recognize, like on the coordinate system, this is the point of origin, or what we might call point 0, 0. So first thing we need to do is find the X and Y bar for each shape. So shape 1, just like I reviewed earlier, it's our base divided by 2. So in this case it would be 3 inches divided by 2, which is 1.5 inches. Y bar, height divided by 2, we are 6 inches tall, divided by 2, which is 3. And then we'll go through the same for shape 2, our triangle, and shape 3. I want you to remember that we're just finding each individual centroid in the X and Y direction. We haven't even talked about this being a complex shape. We're about to do that in just a second. Now let's find the area. So rectangle, 6 times 3, that's easy. Triangle, half base times height. And our square, 3 times 3 is 9. Make sure you're keeping your units, square inches. Okay, here's your equation you wrote down earlier. And doesn't matter if you do X or Y first, let's just do X. So you are finding the X bar for this entire complex shape now. And I just want to walk through what all these values mean. So X bar, let's walk through the equation. X bar equals, sigma means the summation of, this means X bar individual times area individual. Now look over here. X bar individual times area individual. Individual meaning like shape 1, shape 2, shape 3. Now back to the sigma. Sum. The sum of. So it's this times this plus. So X bar times area plus X bar times area plus X bar times area. And then that's all divided by the sum of the individual areas. Individual areas and the sum of them. These little black lines I'm just showing you, this is the area of shape 1, area of shape 2, area of shape 3. We'll simplify all that, and we have an X bar of 2.71 inches. So X direction, here's 3, 2.71, it's just a little bit shy of 3 in the X direction, but we don't know the Y direction yet. Clearly, that's what we're going to do next. It's the exact same thing. Look at what's changed. Only difference is now we're using the Y bar individual. 3, 4, and 1.5. Notice the areas are still the same. We're still talking about the same shape. Still shape 1, still shape 2, still shape 3. Now, this particular example happened to give us the same X bar and Y bar answer. That's not always the case. So if we were to chart that out, we would get X bar 2.71 and Y bar 2.71. Again, that's just this example. They're not always the same. And then finally, the last thing you'll do is on your Centroids worksheet. You might be looking at a version that's slightly different, but read through the instructions. You are going to create a simple centroid. It doesn't need to be really complicated. Read through the instructions and the requirements, do your math in your notebook, and then you're physically going to make it out of a piece of cardstock, and then you're going to balance it on top of my little centroid tester.